Hello, everybody. Welcome to Electronics Market Lecture on Experimental Economics. So, in this lecture, we are going to be discussing, different topics focused on what's the importance of experimental economics, of how we can apply it to doing kind of understanding questions and perhaps providing some answers as well. Okay. So let's start. Economics, we know generally, is observational. Okay, where we observe a phenomena and we make inference out of it, and try to provide the mechanism why this is occurring, etc. Right? But often natural data, which we are looking for, the observational data, often fails to allow for critical testing of theoretical propositions, because the something might be changing because of multiple factors, right? But we want to understand how one of those factors impacts the change. Okay, so often problems arise because of there are different distinguishing historical events that occur only by chance, and we cannot keep creating them. Like, for example, an earthquake. If you want to understand how did something change, kind of the behavior of something, we need a change that is completely independent, especially even if they occur there. Even if these incidents, historical events occur, they're often perturbed by different confounding extraneous factors. What is meant by this is that it might be that the change is occurring because of multiple things happening at the same time. Okay, and so we're not able to pinpoint what is, or at least disentangle what is the exact effect of our variable of interest on the dependent variable. Okay, and these problems become more severe as theories become more precise and intricate. So econometrics is one of the tools that is being used in experimental economics. Is the study of uncontrolled economic field data is usually not sufficient in experimental economics, because so many events don't occur, and there are lots of endogeneity problems and other problems, and it's very hard to get causality. Okay, and thus must be accompanied by a systematic evaluation of economic theories under controlled conditions. A good example of these could be auctions or voting schemes. Okay, let's first quickly go through a nice brief history of experimental economics. So the early experiments happened in 1940s and 1950s. So there was an individual choice experiment by May 1954. It tested the basic theory of uncertainty by von Neumann and Morgenstern. Next, there are also some game experiments, mostly prisoner's dilemma type by Sayert and Love. And finally, some kind of market experiments, which were first reported by Edward Chamberlain in 1948. So let's start with Chamberlain's market experiment. So his approach was simple, right? He took graduate students as economic agents, and so demand and cost structures of each of these agents was induced by randomly by drawing a deck of cards to avoid any sort of sorting or any other confounding effects. Example: sellers receive individual cost and buyers individual value. Okay. Next, they also had something called hypothetical earnings, where they allowed for firms, depending on the cost and value, allowed for some earnings, and students could freely move through the classroom to bilaterally negotiate prices in an unstructured and decentralized market. They wanted to look at a market that is completely free. Okay. And what results they found was, despite the competitive structure and prices systematically deviated from the hypothetical equilibrium price, and there was a tendency to oversupply, and prices were below equilibrium price. Okay. Next came Vernon Smith's market experiment, which was touted as a breakthrough. So Vernon Smith was a professor of economics, born 1927 in the U.S., and he also participated as a graduate student in Chamberlain's experiment. He conjectured that the decentralized market structure was not the appropriate institution for testing the theory of perfect competition, because in this decentralized case, if you go bilaterally, you don't have all information. So there might be some issues where you won't get the results what you find equilibrium, because the results for getting equilibrium are often based on that everyone has the same information, right? And everyone knows what the costs are, everybody knows what the market price is, everything is known, and it's known what each seller and what each buyer's valuation is. Okay, so what he did was to take into account, avoid this decentralized market that Chamberlain did. He did an extension of Chamberlain's experiment, but he devised a laboratory double auction institution. What he did was he made everything public. He allowed the bids, offers, and transaction prices to become public on a blackboard. And then, given this, kind of perfect information among all the participants in the market, or of the economic agents, the market, he noticed that the market price converged to equilibrium outcomes. And so this study by Smith, then Smith decided to study the effects of changes in trading institutions on the market outcome. And in 1992, Smith won the Nobel Prize for basically establishing laboratory experiments as a tool in empirical economic analysis and the study of alternative market mechanisms. So let's try to understand advantages and limits of economic experiments. So the main advantage of experimental economics is replicability. It is basically the ability to reproduce the experiment by other researchers, which is actually crucial to ensure that there is no other confounding effect, or whether the experiment has been done in good faith. Generally, replicability is not possible in non-experimental settings. For example, it might be that the data collection was not done professionally, and further it might be difficult to verify the accuracy of field data, and also it's very expensive to collect field data, or basically natural field experiments was only possible because of a singular historic event, and it's never going to occur. So it's not possible to replicate it again, right? So quickly, going to a small excursus, where what we say is that replication in science is important, but there's a massive problem of replicability of results. And they find that in psychology and cancer biology, the replicability rates were around 40 and 10%, which is quite low. Next, we move on to the main advantages of continue to go through the main advantages of experimental economics. Next, the importance is that control. You have the capacity to manipulate conditions so that the observed behavior can be used to evaluate alternative theories and policies. And it allows for a nice basis for internal validity and understanding of causal relationships. For instance, in the absence of control in natural markets, data may not be collected, or the collected data might be too imprecise to test theory. It might not be possible to test for multiple equilibria. There might be multiple omitted variables, unobservable characteristics, or confining influences, because conditions vary in more than one dimensions, right? That is the problem of confounding variables, right? However, experimental economics is not immune to criticism. There are multiple criticisms. For instance, will students of economics really decide the same way as professionals would? So one suggestion was that a proper choice of the subject pool could be done, and in many situations, it is found that students perform very well as professionals. Another thing was, can simple laboratory experiments really explain complex economic behavior? Next, if a theory doesn't work well within the control lab experiment, will it actually work in the field experiment? Right? So we have to be careful of that we should not oversell the research results. You have to say that it was possible in a controlled environment, and keeping everything else constant. Further, there are also technical difficulties in establishing and controlling laboratory environments. For instance, games with infinite time horizons. How are you going to control that? One suggestion that has been made is the idea of solution for this is the idea of random ending rule, so that nobody knows when it's going to end, and they keep playing as if the end was not nearby. Okay. uh, Another is risk aversion of human subjects, and yeah, that's something that's a difficulty that's there all along. And finally, experimental economics should supplement and not replace other kind of empirical techniques. So it is one more complementary technique to prove results uh, along with others. Okay. So um, let's now move to implementing an economic experiment. First, let's try to understand what are the other types of experiments. Okay. One type of experiment is basically on testing of behavioral hypothesis. It tries to replicate theory. Often it tries to falsify or confirm that the theory makes sense. And there's a close interaction between theory and experimental results. Next, basically, there's something called theory stress testing. What this does is it bridges the gap between theory and naturally occurring markets. This simply because theory often makes multiple simplifying assumptions which may not fit to real markets, and thus the predictability of theory might be questioned, right? So experiments allow to bridge this gap by saying, okay, so we allow for these more complicated kind of environments, and we take into account the theoretical predictions and try to understand what is the middle ground of this, right? So what it's trying to do here is that it tests the sensitivity of obviously unrealistic simplifying assumptions of theoretical models and see where they break down. Again, finally, uh, there's also a third type of experiment, which is searching for empirical regularities or facts. Basically, it tries to verify empirical findings and also in a lab setting to check whether it makes sense. And this is just nicer simply because in an experimental analysis, there's little or no error in experimental data, because all of the data is perfectly controlled for, and it is available in a very controlled environment. Okay. Next. So there's always, in when designing experiments, there's always a choice, a trade-off between realism and models. So it's often the question, which approach is right? Should we mimic reality perfectly, or should we mimic the model perfectly? In the view of this chair, and neither is the right approach. Rather, there has to be a middle ground, simply because not much is learned from experiments which mimic reality or which try to mimic. No one can mimic reality because there are infinite dimensions of variations, and so any experiment that says that it perfectly mimics reality is incorrect. And so we have to be careful, right? And next, what's important is lab experiments should be judged by their impact on our understanding and not by the fidelity or loyalty to reality or to a formal model. So this is more like lab experiments should shed additional lights and light on the economic phenomena, and not specifically on kind of focused on reality or to a formal model. Okay, because none of those perfectly can be done, because reality cannot be perfectly replicated in a lab, and formal models are not a perfect kind of are not a good representation of reality. So we have to be careful and balance the two out. Next, let's try to go into some principles of economic experiments. So it's very important that in experiments, the environment and institution should be very, very well controlled. What does controlled institution means? That the rules of the games should be enforced by the experiment, and and should be clearly kind of communicated with the participants in the experiment. Next, controlled economic environment, is basically, what Smith in his 1976 paper said is the induced value theory. What is this? Control is the essence of experimental methodology, and in experimental exchange studies, it is important that one be able to state that as between two experiments, individual values, demand or supply, either do or do not differ in a specified way. And such control can be achieved by using a reward structure to induce prescribed monetary value on actions. To go into more detail on induced value theory, let's discuss a bit more. In induced value theory, it's important to have a proper use of a reward medium, especially money, which is perfectly allows to kind of incentivize the player to kind of behave in a certain way. This allows the experimenter to induce pre-specified characteristics in experimental subjects, and subjects' other characteristics might become largely irrelevant. So there are three important points of induced value theory. First is monotonicity. It basically means that when you offer a reward medium to subjects, they should prefer more to less. Okay, that means they should prefer more money to less money. Okay, and this can simply be done by using the domestic currency of a country, right? The more money you have, the more happier you are because you can choose to buy what you want. Second, salience. The reward received by the subject depends on the actions as defined by the institutional rules that he or she or they understand. And relation between actions and reward implements the desired institution. So it's important that kind of the as you do a good action, you get higher and higher rewards. So that allows to kind of induce actions in a certain way given the institution that we have built or the rules we have set, okay, in the experiment. And finally, dominance. What is dominance? That any changes in the subject's utility from the experiment should predominantly come from the reward medium, and other influences such as personal characteristics should be negligible. Therefore, in these circumstances, it's very important that the protection of privacy must be ensured, because if consumers know that others will observe what they are doing, then they might not behave as they should if no one is looking, right? And that is what we want. We want that money is the predominant factor that motivates someone to do an action, because that's the reward medium, right? And that should be the dominant one and not someone else judging someone else. Okay, so if these three conditions are met, then the experimenter can choose freely any relationship between intrinsically worthless objects and the reward medium. Next, as long as the experimenter can explain the relationship clearly, which is important, that salience, that the participant should understand the relationship very clearly, and subjects are motivated by the reward medium and are not influenced by other factors. And the concept of salience differentiates surveys from controlled economic experiments. Okay. Then let's go into the do's and don'ts of experimental economics. So first thing, it's important that you should motivate subjects by paying them in cash. That means you should, this way you align the interests of the subjects to behave in a certain way as you would like them. Most of the payment should be linked to a subject's action, that is salience. An average payment should exceed the subject's average opportunity cost, dominance. And it should avoid bankruptcy. What basically means is that it should not be that you cannot pay later on, or that means the subjects will not trust you anymore and will not behave in a certain manner in the next experiments that come. Next, you should find subjects with low opportunity cost and steep learning curves, example students. And next is that you have to create the simplest possible environment so it's clear for the participants to understand what's going on. Okay. And if possible and feasible, maintain the privacy of subjects' actions, payoffs, and your own experimentation goals. Okay. Some don'ts. First, avoid very complicated, words or big instructions, because this will confuse the audience and the participants. Try to use neutral terms of subjects' roles, and tell a realistic story which helps subjects understand, but avoid parallelism with real world. And finally, do not deceive or lie to them. That's a crucial point, because you want the subjects to trust you and to know that if they behave in a certain manner, they're going to get exactly what they want and they're not lie down. Okay. And with all these, kind of do's and don'ts, it's crucial that, then you can do a better experiment and, get also the results that you're looking for. Okay. So next, experiments in field represent an important tool for internet platforms, and many platforms do it. They keep doing it simply because it's cheap to run these experiments, and they have lots of participants who can do so, and without clearly going into detail as to what they're doing. Okay. For example, Facebook did a lot, right, of experiments on their own subjects, and because they knew very well that the subjects would not go away because they are locked in from the network effect. Now let's move on to some design of experiments. So design of experiments should kind of break down. You should break down into different boxes, where one box should be on what are the focus variables you're interested in. That is, what is the variables of interest, and what are the control changes you're looking at that will impact your variable of interest. Okay. Next, now it's important to also understand what are nuisance variables of little or no interest, which may affect results and have to be controlled for. And most simple, control mechanism would be to hold the nuisance variables constant. Okay. For example, see here, a treatment can be that sign up with Facebook, where the button is on the right side, and another button where you sign up with Facebook with button on the left side. So you're basically, what you're doing is you're trying to understand how the positioning of the left and right side of the sign up with Facebook impacts, kind of the how fast do consumers sign up with Facebook. Yeah. Okay. Next important thing is to understand how do you design the interaction between the participants. One is something called within subjects design. That is, the same group of subjects participates in more than one treatment. Okay. An example of this is effects of different types of exercise in memory. So what you can do is you can have two treatments. One is aerobic exercises, that is, participants run for 5 minutes, and anaerobic exercises, where participants lift weights for 5 minutes. And then afterwards, the participants take a memory test. Okay. In this case, within subject design would be that all participants begin first by running and then take the test. After, we have the same group of people are going to lift weights and then take the test. Okay. And then there's one more type of design, which is called between subjects design, where subjects are either in the treatment group or in the control group, but cannot be in both. Okay. So that's basically saying that each subject sees only one level, but different subjects see different levels. What it means is that either participants are going to be only running and taking a test, or some participants are only going to be lifting weights and taking a test. There'll never be a participant who's going to be lifting weights and taking a test, as well as running and taking a test. Okay, that is not allowed in between subjects treatments. Okay. Next, further, it's nice to understand what are constants in treatment. In the lab, many variables can be directly controlled for, in contrary to the field data. So first, constant variables. It's the simplest way to control variables. The more constants you have, that is, more variables you have that you can keep constant, the simpler and cheaper the experiment is going to be. Treatment variables are the ones that you want to understand how they impact your, kind of dependent variable. Okay, which are controlled at two or more levels. Okay. And basic trade-offs are often, between controlling variables and constants, and as constants and as treatment variables should be taken into account. So let me give an example here. Okay, how do you set an experiment with two treatment variables? So what are two treatment variables that we have is this market institutions and demand elasticity. In the market institution, there are two types of it. One is posted offer, or one is double auction. And in demand elasticity, there are two types as well. One, either the demand is elastic or inelastic. And what we want to do is we want to avoid confounding treatment variables, and we want to vary treatment variables independently. Okay, so one simple way to do it is to do what you do is that we take the posted offer and look at how elastic demand, or we take the double auction and look at how inelastic demand impacts it. And the second way that you could do is that you can do that how posted offer and elastic demand play a role, how posted offer and inelastic demand play a role, how double auction elastic demand and double auction inelastic demand. Okay, this kind of the first design A can be confounding, because inelastic demand and the type of market institution can interact with each other, and as a result, we are not able to disentangle why exactly posted offer or double auction plays a role. But if you do this full factorial design, where all four different combinations you can take, then and vary them independently across treatments, then you can understand how exactly posted offer and elastic demand play a role, and you can basically understand and disentangle the effects clearly. Okay. It's also important, there's something also an indirect control, that there are so many factors that we cannot control for. So what we can do is we can randomize the experiments such that these uncontrollable factors cancel out. So for instance, some nuisance variables are difficult to control for example, subject expectations, alertness or interest or weather, right? How can we make these uncontrolled nuisance variables independent of the treatment variables? One is randomization of the assignment of chosen levels, and this allows us to basically shut down anything that we cannot control for, because we assume and because we randomly choose our experiments. Okay, design. Let's start with first control, completely randomized design, which is basically saying that each treatment that we have, the four treatments, are equally likely to be assigned in each trial. Example, in each trial, either one of the four treatments can occur with probability 0.25, and this is very effective because but it necessitates many trials to ensure that there is a predictable power. Okay, the more trials, the less possibility of correlation between the uncontrolled nuisance variables, and as that's the reason we need more trials. Okay, and okay, next we move on to randomized block design, where here what we do is it's more efficient, less trials are needed than complete randomization if nuisance variables can be controlled for. Next, it also ensures zero correlation of nuisance or controlled nuisance variables even in small sets of trial, and one or more nuisance variables can be controlled as treatments, and blocking variables hold constants within a block but varied across blocks, sex, semester, field of study, etc. can be one way to do so. Okay, so general advice: try to block what you can and randomize what you cannot. Okay, so this is a good example here, but basically it's saying that if there's a farmer who wants to understand and has different plots of land and wants to understand how corn and fertilizer interact with each other, right? But he has 5 plots of land. It's not clear how he can devise an experiment. What he can do is, he or she, the farmer, can do is that divide the blocks into each. Suppose the farmer has 5 blocks, can divide the block into 4 different segments where you can interact the corn and fertilizer together, and A, B, C, D, right, together, and then look at how the changes occur across the different blocks. What you do is you remove any other idiosyncratic shocks that might be because the blocks are different types and different different sunlight, different rain or anything. Okay. Some more practical advice that we can give you is that So there are some chronic nuisances that we have to take into account. For example, experience in learning. This can be, beneficial, or it can also hurt. For example, if the experiment is a little bit more complicated, it's good, but you want the participants to understand the experiment thoroughly. It might be good to have some dry runs and teach them how to play, so that there's less experimental or crazy behavior at the beginning when the subjects are trying to learn. And so that's one thing. Next is that there can be other interactions. For example, cheap talk during a coffee break. If there's a long experiment going on, and then you offer the subjects a coffee break, they can go around, talk to each other, and that might affect their behavior later on in the experiment. Also, fatigue and boredom. If the experiment is boring or it is long, then the participants may just click on random things to finish the experiment and leave, right? And then there is selection bias, where the bias can come because some certain people prefer to do more talking than the others, and finally there can be subject or group idiosyncrasies. It's basically saying that subject background or temperament may lead to unrepresentative behavior. And so for this, what you have to do is you have to keep repeating experiments with different heterogeneous subjects to cancel out all of these uncontrollable factors. Okay. Finally, we discussed the disposition of variables. Control all controllable variables, otherwise you have some information loss. Control focus variables as treatments, okay, which is the crucial elements you want to understand how they impact your dependent variable, and then separate the levels of treatments and variables widely. Control nuisance variables as a treatment, okay, and control most nuisance as constants, as many as you can, to keep costs and complexity down, and vary treatments independently to maximize resolution power and to avoid confounding outcomes. Basically saying have a full factorial design. Okay. Some more practical advice. The problems subject face should be reasonably simple, otherwise they'll be confused and they won't give you they won't focus on what you're trying to get them to do. But also framed in a neutral way so it seems simple to subjects. There has to be an upper bound on model complexity for lab experiments, and this comes from the salience element. The incentives provided should be adequate, that is the induced value theory, where the dominance plays a role. And finally, the time allowed for trial and error should be sufficient so that the subjects learn how to actually play in such that their payoffs and what action you're trying to get from them is matches. Okay. Finally, some review questions that we can answer here. What is the main advantage of experimental economics? What is the induced value theory, and which measures for experimental economics does it propose? What is a between subject and a within subject design? What is the treatment and what a nuisance variable? And what is meant by a full factorial design, and what is a random block design? Thank you.